Alright, today we're looking at lesson 7.4. We're going to be solving logarithmic equations and inequalities. Alright, first off, of course our Pascal is covered right here. That's Pascal 2.5b. Alright, logarithmic equation, basically that's any equation that has a logarithm in it. So, when we're getting ready to work through this one, what we want to do here is basically translate this over just like we were working with last week. X equals 8 to the 4/3 power. Now, okay, so once you've translated these over, let's go ahead and change 8 to the 4/3 power. Now 8, of course, is 2 to the 3rd power. So we have 2 to the 3rd to the 4/3 power is x. Now 2 to the 3rd to the 4/3 power is basically 2 to the 4th. Remember, multiply your powers. X equals 2 to the 4th, so x equals 16. Alright, that's your basic equation. Now we'll kick it up just a little bit here, and we'll look at this type of equation right here with logarithms on both sides. The main point is, if we got a log base 4 of something equals log base 4 of something else, since the bases are the same, then this and this are also equal, since they're equal. So, just use that little fact right there and set up your equation like this. Now you're going to solve this quadratic. So we're going to get everything on one side. I've got my x squared over here. I need to move my minus 6x over. It becomes plus 6x. I need to move my minus 8 over. It becomes plus 8. That's equal to 0. Now I use the skills I've taught you in the past to solve this thing. I'm going to factor this one because it's easy to figure out two numbers that multiply to get you 8 and add to get you 6. So we have x and x. Signs are the same. They're both plus. And we know that the two numbers are 4 and 2 because they multiply to give us 8 and add to give us 6. So this would show us our solution on this one. Remember, it's the opposite of that. Our solution set is -4, -2. Alright, and that's basically all you need to know right now for solving equations. Let's take a look now at the next part, logarithmic inequality. I'll go back and show you just some basics here. Let's suppose that I say that log base 2 of 8, we know that's equal to 3 because 8 is equal to 2 to the 3rd power. Alright, however, let's suppose that we had, instead of a positive 8, let's say we had a negative 8, and we weren't sure what that was. Okay? Then we just set that equal to x. Okay, log base 2 of negative 8 equals x. That implies that negative 8 is equal to 2 to some power. Now there's no power of 2 that we can take and get a negative answer. You know, if you go positive, it just gets larger, 2, 4, 8, 16, 32. If that power is a negative, it gets into a smaller fraction, 1/2, 1/4, 1/8, 1/16. And of course, if x is 0, then that's 1. So there exists no solution for this one. So this thing right there can never be negative. Now let's look at it, what would happen if it were 0. Log base 2 of 0 equals x. Well, once again, you have the same situation. There's no power that you can take 2 to get 0. The same reasons as this up here. So one of the important parts of this, inequalities, and get rid of that for just a second. One of the important parts that you have to do is look at both this term and the overall term. So first off, part A, I know that x, that whatever number x is, it cannot be 0, it cannot be negative. So it's got to be greater than 0. Now part B, we're just going to look at this, and we're going to rewrite it, x is greater than, and that's 6 to the 3rd power. Similar to what I did in the first example today. And so if I take x is greater than 6 to the 3rd power, That's going to be 216. Well, naturally, because x is greater than 216, it's going to be bigger than 0. I do not need this answer. Right here is my final solution. But let's look at what happens if this sign were turned around. In other words, if I had log base 6 of x is less than 3. Okay? But once again, I know that whatever x is, it's got to be greater than 0. Alright? Now going back and doing the same thing here, except now the sign is different. So this is part B. I know that x is less than 6 to the third power. So x is less than 216. Now since this says that x is less than 216, I also know that x has to be greater than 0 based on this statement. So in this situation, I would need 0 is less than x, I'll just turn this around, is less than 216. So you've got to put a little thought into this as to whether you need part A, part B of the parts. Now, our fourth example today, this one, we've got 3 parts to work with. The first part, just like before, I know that this thing cannot equal 0. It cannot be less than 0. So 2x plus 8 has to be greater than 0. Now solve this. Subtract 8 from both sides. Divide both sides by 2. So whatever x is, to keep this from going negative or becoming 0, x has to be greater than negative 4. Right? Call that A. Now I go to part B. We look at our second one. This. I know just like this one cannot be 0 and negative, this one, neither can this one. X plus 5 must be greater than 0. X must be greater than negative 5. Now since this statement said that x has to be greater than negative 4, naturally it's going to be greater than negative 5 as well. So I don't really need this one, but I don't know it until I figure it out. Alright, now our last part is the overall problem, in which I use both this and this. I know that 2x plus 8 has to be greater than x plus 5. And the only reason I can do this is because, once again, the bases are the same. Now, to solve this, let's subtract x from both sides. 2x minus x is x. Let's subtract 8 from both sides. 5 minus 8 is negative 3. Now, think about this. If x has to be greater than negative 3, naturally it's going to be greater than negative 4. And so I don't need this one either. So right here is my final solution. Okay? Now one more thing. I'm going to make one up here. Log base 3, 2x plus 5 is less than equal log base 3 of 5x plus 4. Just making this up. Just like we did before, let's look at this first part. I know that 2x plus 5 has to be greater than 0. So 2x has to be greater than negative 5. So x has to be greater than negative 5 over 2. Right? Second part. I know that 5x plus 4 has to be greater than 0. So 5x has to be greater than negative 4. So x has to be greater than negative 4/5. Alright? Now since it's got to be greater than negative 4/5, naturally it's going to be greater than negative 5/2, which is negative 2.5. So this one's not necessary. Now part C, the overall. I know that 2x plus 5 must be less than or equal to 5x plus 4. Subtracting 2x from both sides, 5 has to be less than 3x plus 4. Subtracting 4 from both sides, 1 has to be less than 3x. Dividing both sides by 3, 1/3 is less than or equal to x. Let's flip this around to compare it to these. X must be greater than or equal to 1/3. Once again, I don't need this one, because if it's greater than 1/3, it's naturally going to be greater than -4/5. That's the end of today's lesson. Tomorrow we'll begin working with approximating roots.